Okay, so this is the last part for the first day. So we have 5.3, the Bohr model of the hydrogen atom. Okay, so from the previous uh, discussion about the electromagnetic radiation and matter, there is a slide showing the visible light spectrum. So if you try to recall that slide, so there is a continuous uh, change in the color or change in the wavelength. Okay, and it contains all colors from violet up to the red. Okay, so we call that as continuous spectrum, just like this uh, image. Okay, so continuous spectrum, so that contains light of all wavelengths in the visible region. So all wavelengths. So that means there must be no gap between those uh, colors. So that can be seen when white light. So for example, we have a white light here, okay, from the back side of this picture. So if the white light is passed through a prism, so after passing through a prism, it will diffuse all the wavelength of the light. So we'll have the continuous spectrum. Okay. So what about if we have elements? Okay, so for example here, we have a gaseous element, so elements in a gaseous phase, and then we connect it in a high voltage source wherein there will be energy that will flow through it, or the electrical energy that will flow through it. So it will become energized. And from Max Planck's theory or quantum theory, so it will absorb energy, and after absorbing the energy, so if we try to switch off this uh, energy source, so there will be an emission of energy. So that energy, since the element now has, for example, this is hydrogen, for so if the element is excited or the hydrogen is excited, so it will contain those quantized amount of energy, and if it will emit those energy, so it will be also in quantized form. So it's the energy, okay, so or in the form of light energy, so it will pass through a slit, okay, and then this slit will just have a band of what is emitted, and then if it goes to the prism, it will just have this uh, colors in the screen or in the detection center. Okay, so for hydrogen, so we only have four. For mercury, we have multiple as well, as in the neon band. Okay, so if we try to see the hydrogen band or the hydrogen uh, band, yes, band, not bond. So we have four bands. Okay, and this one is not continuous. So this one is, we have just particular wavelengths. So this is still a spectra, but we call this as line emission spectra or line spectra. So line emission spectra are just lines of different wavelengths generated from an excited or energized elemental source, just like what is in the experiment from the previous slide. So this means that the hydrogen gas only accepts or absorbs and emits this particular wavelength, and this corresponds to particular energy from Max Planck. So we have this wavelength or this frequency, and then if we need to convert that into the energy it absorbed, so we just have the formula E is equal to H nu. Okay, so how do these atoms try to absorb or emit those energies? Okay, so inside the atom, we have particular energy levels. So we have n is equal to 1, 2, 3, and so on, up to the infinite energy level. And in these energy levels, we found those electrons. So we cannot find electrons from this one, since this, from this energy level to this one, so that is a quantized energy. Okay, so for example, we have an electron from the sixth energy level going to the first energy level. So, meaning in this n is equal to 6, there is the energy or energized electron, or we say as electrons in the excited state. So, it will come down into a lower energy level or lower energy. So, this means that it will emit a particular wavelength, or it will emit energy. So this energy is in the ultraviolet region. So we can also have n is equal to 5 going to n is equal to 1, and so on. Okay, but what we are more particular with is this transition. So we have n is equal to 6 going to n is equal to 2. So this is 410.2 nanometers. So this will fall into the visible light region. So this is actually what we see, okay, in the bands. So the n is equal to 6 to n is equal to 2, n5 going to n2, n is equal to 4 going to n2, and n is equal to 3 going to n is equal to 2. So these 4 transitions we see in the visible region. Okay, so that is why from the previous experiment, we only see 4 bands. Okay, so if we have some transitions from higher energy level going to n is equal to 3, it will fall into the infrared or IR region. Okay. So we try to first define the states of the electrons or atoms. So excited state, so this is also an energized state, or the state of the atom after an electron absorbs a quantized amount of energy. So this atom has electrons from higher energy levels. And then ground state, so this is when the electrons of the atom are arranged to give the lowest total energy. So that means that the electrons are found in low energy levels, or n is equal to 1, n is equal to 2, as long as the electrons are in the low energy levels, we say that is in the ground state. Okay, for hydrogen atom, the emission lines in the ultraviolet region are due to these transitions. So if we try to recall the penultimate previous slide. Okay, so we have n is equal to 6 going to n is equal to 1, n is equal to 2 going to n is equal to 1. They all fall in the ultraviolet or UV region. So we have this IR, okay, going to n is equal to 3 or n is equal to 4 transitions. So again, we're particular with the visible region, wherein the final destination is n is equal to 2 transition. Okay, so let's have some problem for 5.3. So in which of these electron transitions in the hydrogen atom is energy emitted, and in which is it absorbed? So just look at this transitions, okay, and then try to figure out if the energy is emitted or the energy is absorbed. So again, you can pause this video and solve this on your own. Okay, so here is the answer. Okay, so let's try to put this side by side. Okay, so for letter A, since we have n is equal to 3 going to n is equal to 2, or higher energy level going to a lower energy level, so the energy is emitted. For this letter B, n is equal to 1 from lower energy level going to n is equal to 4 high energy level. So the energy is absorbed by the electron. So n is equal to 5 to n is equal to 3, energy emitted. N is equal to 6 to n is equal to 2, the energy is also emitted. So this means that if the electron goes from higher energy level to lower energy level, the electrons are emitting certain amount of energy, while if it goes from lower energy level, it will absorb energy to go to the higher energy level. So I hope that this 3 videos, you'll understand the concept of this electromagnetic radiation, as well as how this electromagnetic radiation transfer the energy, and we are particular with the electrons at this point. So that's it for today.